So this is a hotel they built in Anaheim. It's called the JW Marriott Anaheim, and it's a 12-story high-rise overlooking Disneyland. They had a really cool bar at the top that you could see it was an outdoor bar, or it is. I sent my son there for his honeymoon. They love Disneyland, him and his wife. And anyway, you could see the fireworks from the balcony. So as you can see, this rebar is extremely congested, and they had to get the engineer to rethink this thing because you couldn't even get the concrete in there, as you'll see with these photos coming up here shortly. Let's see here. So as you can see, was it was just too much, and those are number 11s. So these mat footings are about 8 feet deep, and there's 3 of them. They're pretty big, and you could fit, a school bus in there. Here's us assessing the amount of rebar and how they're gonna put a vibrator down there to even consolidate it. So it was crazy. So anyway, that's what happened here. A lot of steps in it, and bundled bars here and there, and oh man, it was quite a bit. And coming up here, it took all night to pour this thing. As you could see, these videos coming up, it was a tremendous amount of concrete. They worked all day and into the night and into the next day, just pumping concrete, with lots and lots of trucks. So as you can see, we're coming up to the first pad footing. I don't know if you want to call it. Anyway, those dowel-ups are going to be all the shear walls, and they go up 11 stories. And then as you can see back there, oh, you can't, there we go. There's another one. You can't tell, but those are very deep. They're 8 foot deep, and the footprint you can't tell either. This crane right here, I'm going to go up like that, and it's going to be 11 stories. So 11 stories plus, I think, a little doghouse above our elevator shaft. So on to the next clip. All right, so here we are. We're coming up out of the footing with some rebar for the shear walls. A lot of ties. Oh my gosh. These came assembled on the truck, and just they craned them in. Here's where they missed the rebar. A couple of bars within the footing they had to drill down, and for the shear walls, and epoxy them in. And this next clip right here, he's cleaning them out. He looks happy right here. But anyway, so it goes. We miss bars sometimes. Here is some congested rebar that I would like to show. How are you supposed to get concrete in there? This engineer, I'm not sure. They really put a lot of rebar in there. It's crazy. The building next door that they were building didn't have half the rebar. Here's that shear wall with that's for the elevator core. Okay, so here we are. Here's a slump test. This is how they test the water within the trucks as they show up, and they just put some concrete in this cone-shaped thing, and they called a slump cone, and then they rod it and everything, and they pull it up and they measure how much it drops, and that tells you how much water is in the concrete. Okay, well, this is the result of too much rebar. A congested wall with a tremendous amount of rebar and no room for the concrete to go or for proper consolidation to happen. So what they did was they did external vibration. They did everything right. The free fall of the concrete, no more than 4'6", I forgot what it was. They did everything right. So as a result of this, external vibration as well on the outside of the wall as they were placing the concrete. So they had to fix it, and they chipped all the concrete away, and they do this two-part system, and it took them weeks to fix all these rock pockets. This is only a small amount of what happened. So the engineer approved this Part A, Part B system. They had to dig down to solid concrete into the rebar and form it up on the sides and re-pour where all these rock pockets were. And it was really bad, and everybody was blaming everybody. But anyway, that's how it goes sometimes. Applying this two-part system, it's a two-part epoxy system to help it stick to the concrete. Getting it all prepared. Then they form it up, as you can see here, and they poured in that little hole up top. You see the guy with the bucket, and that's how they do it. Well, here's some shear walls for you. Quite a bit of rebar in these walls. Just, anyway, this building's not going anywhere. If you want to know what's inside these buildings, here you go. Here's some good shots of concrete, reinforced concrete walls. So these next clips show how they get it up there, 11, 12 stories with this crane. So coming up next is my little plans table. It's got to be near the porta potties, of course. Got my little umbrella. So this is the cure box. By code, you have to put the cylinders in a cure box. Within 24 hours, the guy picks them up. After 24 hours, you can't touch them. And in that cure box, what I put in there was the mix designs. If you could see here, I don't know if you could see it. These are all the approved mix designs, so when the ACI technician shows up, he knows exactly what slump and everything is supposed to be, as well as I had 11 by 17 laminated on there, and I would circle the areas that we were placing depending on what level we're on with a dry erase pen. That way I could just erase it. And yeah, so that made my life easy if I just go the extra steps. Okay, so here's our slab on grade, and it's just some mesh, and that yellow stuff you see is vapor barrier. They call it Stego, I believe. Yeah, it's just a brand name like Crescent Wrench or anything else. And so here we are pouring the concrete on the slab on grade. So the foundation and the columns get placed first, and then if you notice there is they keep the slab on grade separate from the columns and the foundation because they settle at different times, and that's to help reduce cracking and things like that. There's a little thickened edge. You kind of missed it a little bit right there. Those are little chairs, those black things that holds the mesh up. And it's not sitting on the chairs yet, I don't think. Because what we would do is, yeah, they are sitting on the chairs. But a lot of times they put them on the chairs and then you walk around and you just smash the mesh down, which is just little wire mesh. It's little, basically reinforcement. There we go. There's some slab on grade. Doesn't look like they have vapor barrier on this. Huh. That's the basement area. Here's what it looks like when it's complete, or getting complete. Nice and beautiful. Okay, let's get into some elevated decks. These are post-tension, meaning we stress the cables after concrete placement. I wonder how to explain this. So what happens is these cables go through these blue sheaths. You see the blue sheathing, and so the concrete hardens up or cures around the sheathing, and then they pull the cables, which when these cables have these profiles, they go up and down and up and down at certain areas that the engineer designates, and they create positive and negative moment. meaning they push down and push up at the same time. And that's what carries these parking structures. If you ever walk in a parking structure, you'll see that the concrete decks that are holding your cars are only about 5 inches thick. What this does is reduces a whole bunch of rebar and the thickness of the deck and things like that in cases like this, so they can create more headroom space, so you're not loading it up with big heavy pieces. Now this is a profile, so the engineer will designate where these cables are placed. I'm doing a horrible job at explaining this. So they'll have certain areas in the deck where the cables will be a certain height, a little bit high over here and low over there. Typically on columns it'll be high, and then low in the center of the deck. So where the column line is, the cables will be up high, and then they go low and high, and they create profiles, as you can see here, perfect. So they go high right there. This is a banded system as opposed to a beam and girder system. If you notice, there's a whole bunch of cables running through that column right there. Let's call it north-south. And then let's call it longitudinal. And then your transverse ones running right to left go up over those. And then when the concrete cures, you stress those cables and it holds the deck in place. There's much more to it than what I'm explaining. These are sweeps, and so they sweep around areas, and you have to put hooked rebar around the cables. If you can imagine, when you pull these cables, they're creating tension, or they're creating forces towards you in this case. So we put what's called hairpins, and they're these U-shaped rebar around the and you see there's a piece of mechanical penetration coming through, so we got to get it around that or it'll blow those out. These are the anchors. These are the points where you stress the cables. The concrete gets placed over those red things and the blue things, and these are the anchors. These are deadheads, or actually live ends, I'm sorry. These are the live ends of the anchors. So the concrete will come up to the top of that piece of wood right there and cover all those colors right there and all the rebar. And then just on the other side, which is called a delay strip, you will put a jack on that end and pull these cables to their specified strength, which is 70%. I wish I had the information off the 70% of its total yield strength or something like that. Don't quote me on that. I should have done my research before commentary on this video. Anyway, we got some more anchors coming up here. Let's see what we got. So within these anchors, you have what's called bursting cages. And it's just a bunch of rebar. As you can see, there's hairpins, those U-shaped rebar. Those go around transverse rebar. And what that does is helps the anchor stay in place when you're stressing all those forces on the edge of the concrete right there. Yep, so that's what that is. Let's see what we got here. So here's a tremendous amount of PT cables. So this was for the swimming pool that was elevated above the ground. And so it took a lot of PT cables. It just looks like a rat's nest in there, as you can see. And so this would be a beam and girder system, not banded. So meaning it will go into beams and girders. As you can see here, I don't know how to explain this one, but this is just, I was inside there counting these cables. It was not easy. Make sure they're all there and checking proper profiles, where it sweeps up and sweeps down. It's a lot of work, and it takes a tremendous amount of oversight to check all these cables. And but so here's the anchors, the live ends. So this is where they put they put this calibrated jack on the ends of these cables, and it's a hydraulic jack, and they just pull these cables to a certain amount. And sometimes we get blowouts, sometimes they fail, and we have to close off the whole area where we are stressing these cables so nobody gets hurt. But not a lot of people abide by that rule. Anyway, that's part of it. This is a lot of cables. You rarely see this. This is to hold up a swimming pool on a second level. So you're not going to really see this many cables in a job that often. Okay, this is that delay strip that I was referring to. Concrete is placed on one side and then the other side, and then within they need an area to stress these cables, so they leave a piece out, and then they stress the cable on one side and the other side, and then they fill that in with concrete. So that's what a delay strip is. Okay, this is really interesting. What they do is they just poured this concrete. This is a concrete deck, and you have your columns and shear walls coming out of it. And so in the same day, they use a high early strength concrete that sets up basically in the same day that they pour it, and then they set their forms around these columns and these shear walls, and then pour those in the same day. And that's how they get production done. So, and then you'll come back the next day and stress the cables that are within the deck. It's a very fast process. Yeah, let's see if anything else comes up. I hope I'm explaining this correctly. Well, let's throw a couple of pretty pictures in there. They wanted to use some of my photos for an engineering magazine, and I applied for it, but I never made the cut. Anyway, worked all hours of the night. Well, let's start wrapping this video up. As you can imagine, it takes an army of skilled tradesmen to put these types of high-rise buildings together. So this is an all-hands meeting where every Monday they all group up and we talk about safety issues or what have you. But you can only imagine all the different personalities, and you make a lot of friends too. A lot of acquaintances. Actually, most of my acquaintances is through work. I mean, I don't drink or or socialize too much. I just work a lot, I guess. So yeah, it's a lot of personalities, and you learn a tremendous amount about how buildings are comprised and put together, and it's insane. Actually, there's too much to learn when you're talking about all these different disciplines. That concludes this video, mainly of concrete and PT tendons and how they put it together. There was a lot that needed to be said about how they move the rebar up there and all that I didn't put in there. But anyway, I got as much information as I can in there, and I hope whoever watches this enjoys it. Thanks for watching.